In this lecture, we are going to prove time reversal property of DFT, and the statement says that if DFT of x of n is equal to x of k, then DFT of, in time domain, if we have a time reversal, DFT of x of minus n mod n is equal to, in frequency domain also we will get x of minus k mod n. This will be in frequency reversal. I mean to say, in time domain, if there is a time reversal, in frequency domain there will be a frequency reversal. So proof. So what is DFT of x of n? As per the equation, it is summation n varying from 0 to n minus 1 x of n e power minus j 2 pi by n into kn. So what we will do, we are going to change x of n to x of minus n mod n, and this is equal to summation n varying from 0 to n minus 1. So this exactly has to come here, right? So this exactly has to come here, no? So x of minus n mod n into e power minus j 2 pi by n into k n. Now I am going to put before that, so I can write this equivalently as, this is equal to what? Summation n varying from 0 to n minus 1 x of, so what is this in terms of capital N? So this n will go to the beginning n minus n, and I have to remove one outer bracket, right? So this x of minus n mod n can be equivalently written as x of capital N minus n into e power minus j 2 pi by n into kn. Now I'll put n minus m is equal to n minus n is equal to m. N minus n is equal to m. And what is n from this? If I write it in terms of n, what do I get? So I get n is equal to n minus m, right? So therefore, so what is the next step? DFT of x of minus n mod n is equal to, so summation, so I am writing n as what? N minus m. So n minus m is equal to, what is this? 0 to, what is n again? N minus m is equal to, right hand side is n minus 1 x of, so n minus m I am replacing it by m into e power minus j 2 pi by n into k into, so what is n? N is n minus m. So this is equal to, so if I write it in terms of m, so what happens? Summation m is equal to n to m is equal to, so n cancels out, minus minus cancels out, I get m is equal to 1. So x of m e power minus j 2 pi by n into k into n, I'll be splitting this exponential, this into e power minus j, so minus into minus plus j into 2 pi by n into k into m. So here n cancels out, e power minus j 2 pi into k, right? But what is k? K is varying from where to where? K is varying from 0 to n minus 1. So it's an integer. So integer multiple of e power minus j 2 pi is always 1, right? So this is equal to 1. So this is equal to what? Summation. Now instead of writing n to 1, I'll write it as m varying from 1 to n. I can interchange the order of summation. Instead of adding from left to right, if I add it from right to left, I get the same result, right? So I can do like this. So x of m into, what is the left term? E power j 2 pi by n into k into m. So this is equal to summation m. So instead of writing 1 to n, I will write it as 0 to n minus 1. So anyhow, I will be end up with totally capital N number of samples, right? So 1 to n is the number of samples what do I have from 1 to n is equal to the number of samples what will be having from 0 to n minus 1. So I can write like this. Instead of writing 1 to n, I can write it as 0 to n minus 1. So x of m into e power j 2 pi by n into k into m. So into, I'll put one more term 1. Okay, now, so instead of writing 1 here, I can write it e power minus j 2 pi by n into m. This is equal to 1, right? Why? Because n cancels out, again e power minus j 2 pi into m, and where m is an integer, so integer multiple of 2 pi of e power minus j will be always 1. So what I'll do is, I'll write, instead of writing 1, I'll write this term. So this becomes summation m varying from 0 to n minus 1 x of m e power j 2 pi by n into k into m into e power minus j 2 pi by n into m. Right? So in the next step, so what I'll do is summation m varying from 0 to n minus 1 x of m e power, I'll take minus j 2 pi by n m. These are the terms I'm going to take common. What is the left out term? So it is e power minus j 2 pi by n into n, and what do I get? Minus into minus plus e power j 2 pi by n into k. Right? Before going to the next step, see if summation n varying from 0 to n minus 1 x of n e power minus j 2 pi by n into k into n is equal to x of k, right? This we know, right? This is from the DFT equation. So what I'll do, instead of writing this k, I'll write it as n minus k. Fine. Instead of writing k, I'll write it as n minus k. What happens to the right hand side? In the right hand side also, this will be replaced by n minus k, right? So summation n varying from 0 to n minus 1 x of n e power minus j 2 pi by n into n minus k into n can be written as x of n minus k, right? So therefore, in the previous step, this is what I got. So what I'll do, instead of writing this, I can write it as what? I can write it as x of n minus k, right? So therefore, what is the left hand side? So what is the left hand side we had? The left hand side what we had was DFT of x of minus n mod n. This is where we started, is equal to, where did we end up with? X of n minus k, right? And if I take this n as a mod and I'll put one outer bracket, right? I can write it equivalent to something like this, no? So this is nothing but x of minus k mod n. What is the left hand side? DFT of x of minus n mod n. So this is what we wanted to prove. It's a time reversal property.